Why do we administer tests? Traditionally, tests have been used as a tool to judge a student based on merit. It is used to determine whether students have learned what they were expected to learn. It can also be used to gauge the level or degree to which students have learned the material. Also, they may be used to measure the learning progress and achievement of the student and to evaluate the effectiveness of an educational program. Indeed, tests serve a vital role in the educational system. Thus, tests must be constructed carefully. But there is no such perfect as far as test is concerned. Here comes item analysis. How are you going to determine if an item is easy or difficult? How do we measure item difficulty? How do we know if an item discriminates students who mastered the topic from those who did not? How do we measure item discrimination? Good day, everyone. I'm Hero S. Pedrosa, PhD Mathematics Education student. Join me as I discuss my report entitled Relationship between Difficulty Index and Discrimination Index of a Test. Here are the objectives of this report. Describe the relationship between difficulty index and discrimination index of a test. Apply difficulty and discrimination index in several examples. Interpret results of an item analysis based on difficulty and discrimination power. As we all know, most of the teachers are conducting item analysis after administering and checking the test. Item analysis is a tool used in improving the quality of teacher-made tests. Here are the benefits of item analysis procedure according to HINA 2015. First, it gives information on item difficulty. Second, it gives information on item discriminating power. Third, it gives insight for better test construction. Fourth, it gives data for students' improvement of learning method. And finally, it gives information of class discussion of the test. Our focus are the highlighted terms, item difficulty and item discrimination. Here are the procedures that we follow in conducting the item analysis. First, get the total score of each student or test taker. Second, arrange the test scores from highest to lowest. Third, obtain the upper and lower 27% of the group and make an organized list on a table. Some authors get the upper and lower 50% of the group. Fourth, compute the proportion of each item in the high and low group. And last, compute and interpret the difficulty index and the discrimination index. What is difficulty index? It is the proportion of students who answered the item correctly. It actually measures how easy a question by determining the proportion of students who got it right. Basically, the item is easy if the majority of the students are able to answer it correctly. Now, the formula that we're going to use for finding the difficulty index is the proportion of the high group plus the proportion of the low group divided by 2. Now take a look at the table. If the difficulty index is 0.24 or lower, it is considered a difficult item. While if the difficulty index ranges from 0.25 to 0.75, it is considered an average item. And if the difficulty index is 0.76 or higher, it is considered as an easy item. Let's have an illustrative example. 10 students took a teacher-made test, and the results are shown below. The teacher checked the test papers. Then, he conducted item analysis by showing the correct and wrong responses in a distribution table. Take, for example, student 10 with a total score of 4 got correct responses in item numbers 2, 3, 4, and 5. The first step is to get the total score of each student or test taker. On the table are the details for each student's performance in the test. Correct responses is denoted by 1, while 0 for wrong answers. Scores were counted and summated in the last column. Second step, arrange the test scores from highest to lowest. The highest scorers are students 3, 6, and 10, while the low performing are students 1, 7, and 9. The rest are considered the middle or average group. Step number 3 is to obtain the upper and lower 27% of the group and make an organized list on a table. 27% of n is actually 27% of 10, the number of student takers. 0.27 times 10 is equal to 2.7 and rounded to the nearest whole number, which is 3. So therefore, each of the group consists of 3 students. Thus, students 3, 6, and 10 belong to the high group, while students 1, 7, and 9 are in the low group. Fourth step is to compute the proportion of each item in the high and low group. The formula that we're going to use is proportion equals correct answer per item all over total number of students in the group. For item number 1, the proportion of high group is equal to 1 over 3, which is equal to 0.33. The proportion of the low group is equal to 0 divided by 3 equals 0. For item number 2, the proportion of the high group is equal to 3 over 3, which is equal to 1, while the proportion of the low group is equal to 1 over 3 equals 0.33. For item number 3, the proportion of the high group is equal to 3 over 3, which is equal to 1, while the proportion of the low group is equal to 2 over 3, which is equal to 0.67. For item number 4, the proportion of the high group is 2 over 3 or 0.67, while the low group is 3 over 3, which is 1. For item number 5, the proportion of the high group is 3 over 3, which is equal to 1, while the low group is equal to 0 over 3, which is 0. In computing the difficulty index, the formula is P equals the proportion of the high group plus the proportion of the low group all over 2. We are guided by the table for interpretation. On the second and third row of the table are the proportions of the high group and the low group that we solved a while ago. Now let us solve the difficulty index for each item. For item number 1, the difficulty index is equal to 0.33 plus 0 all over 2 is equal to 0.17 interpreted as a difficult item. For item number 2, 1 plus 0.33 all over 2 is equal to 0.67, which is an average item. Item number 3, 1 plus 0.67 all over 2 is equal to 0.84 interpreted as an easy item. Item number 4, 0.67 plus 1 all over 2 equals 0.84, which is also an easy item. For item number 5, 1 plus 0 all over 2 equals 0.5, which is an average item. Now let us define discrimination index. It is the proportion or measure of the extent to which a test item discriminates or differentiates between students who do well on the overall test and those who do not do well. There are three types of discrimination indices. First, positive discrimination index is a scenario wherein those who did well on the overall test choose the correct answer for a particular item more than those who did poorly. The negative discrimination index, on the other hand, is the exact opposite of the positive discrimination index. Those who did poorly on the overall test choose the correct answer for a particular item more than those who did well. While zero discrimination index is a scenario wherein those who did well and those who did poorly in the overall test chose the correct answer for a particular item with equal frequency. Discrimination index can be solved using the formula D equals the proportion of the high group minus the proportion of the low group. If the discrimination index ranges from 0.4 to 1, it is considered a very good item. If it is 0.3 to 0.39, it is a good item. While if it is 0.20 to 0.29, it is considered a reasonably good item. If it ranges from 0.10 to 0.19, it is considered a marginal or average item. While if it is from -1 to 0.10, it is considered a poor item. For the action, if the item is good, it will be included or retained, while for marginal and average item, it will be revised or improved. For poor items, the action is to remove or eliminate the item. These two indices can also be related using the table showing different scenarios of difficulty level and discriminating level with corresponding actions that will be taken. This summarizes that if the item is very discriminating, it will be retained or accepted. If the item is moderately discriminating, it will be revised or improved. And if the item is not discriminating, it will be removed or eliminated from the test. Going back to our previous example, using the same table which shows the proportions for high group and low group, we can get the discrimination index easily by subtracting their proportions. For item number 1, the difficulty index is 0.33 minus 0 is equal to 0.33, which is interpreted as a good item, thus the item will be included or retained. For item number 2, the difficulty index is 1 minus 0.33 is equal to 0.67, a very good item, which must be included or retained. For item number 3, the difficulty index is 1 minus 0.67 equals 0.33, which is a good item and must also be included or retained. For item number 4, the difficulty index is 0.67 minus 1 is equal to negative 0.33. And since it is negative, so it is interpreted as a poor item which must be removed or eliminated from the test. For item number 5, the difficulty index is 1 minus 0 is equal to 1, which is also a good item, and it must be included or retained in the test. Now here are some of the important guide questions when conducting quantitative item analysis. First, what is difficulty level? What is the discrimination index? Should an item be eliminated? Should any distractor be eliminated? Now let's have this example. In a test with 28 takers, The result of item number 3 is shown below. Here, the upper and lower 50% were taken. The correct answer is option A, and the proportion of the high group is 0.29, while the proportion of the low group is 0.07. What is the difficulty level? It can be solved using the formula proportion of the high group plus the proportion of the low group all over 2 equals 0.29 plus 0.07 all over 2 equals 0.18. How about the discrimination index? Here, we can solve using the formula proportion of the high group minus the proportion of the low group equals 0.29 minus 0.07 equals 0.22. Should an item be eliminated? The item must be retained since it is positively discriminating. However, the item is considered difficult because only 18% of the class got it right. Thus, the item must be improved. Should any distractor be eliminated? Remember that in order for an item to discriminate well, more students who do well on the test should choose the correct answer than those who do poorly. Therefore, the distractor should be negatively discriminating. Fewer students who do well on the test should choose each distractor than those students who do poorly. Going back to the item, the answer is yes. Distractors C and D have attracted more test takers who do well in the overall test. A good item will be made better if these distractors are modified or replaced. Now let us have the pre-test as the low group and the post-test as the high group. Here is our example. In a test with 25 takers, the result for item number 5 is shown below. The proportion of the high group in the correct answer, which is letter D, is 0.84, while the proportion of the low group is 0.24. The difficulty index is 0.54, while the discrimination index is 0.60. This approach requires administer the test as a pre-test before the instruction. Ideally, majority of test takers should answer most of the questions incorrectly on the pre-test and correctly on the post-test. For the difficulty level, there is an improvement from 24 to 84%, while for the discrimination index, the key correct option is discriminating positively. In order for us to construct good tests, let us always remember the following. First, construct a teacher-made test which consists of easy, average, and difficult questions. Make sure that it will yield to positive discrimination indices. Second, maximize the use of the difficulty and discrimination indices in improving your tests to establish a stronger reliability and validity of the test results. Should you want to read more about the topic, here are the references and online links that I used for my presentation. Let me end my discussion with this quotation: "Consistency is more important than perfection." Thank you for listening, and God bless us all.